Right, I'm going to just talk you through the vectors. Right. A vector has got two things going on. It's got the magnitude, which is the size of it, and the direction. A scalar has just got a magnitude. So basically, if I said to you a length of a line is 5 centimetres, that's just a scalar because it's just got the length of a line. Okay? A vector would give you the length of the line plus the angle it makes. So that's the difference. Okay? A vector is written as a bold letter or an underlined letter. So you know the way if I said to you that measure the length of this line and you wrote the line A equaled. If it was a vector, it would be underlined or else written in bold, and you would have to give the length of the line, call it R, plus the angle. Okay, so A on its own is just the length, which in this case would be R. The vector A would be the length plus the angle. So if you just get that first of all into your heads, okay? So the magnitude, the size, and the direction. Now, see this here vector? It can be split up into two. It can be split up into how far it is going across and up. It's a bit like you're resolving forces. The across one, if you think about I'll just go back to your resolving forces. You've done these with Mr. Graham. You know when you're bringing it down, you're closing the angle. So your x distance is called r cos theta. And when you're bringing it up, your y distance is called sine. Okay, so that's what I'm doing there. So x and y. In vectors, x is called I and j. Okay, so let's look at what we have so far. So r cos theta is the x distance going across, r sin theta is going up. See, to get this distance here, you use Pythagoras. So if you think about Pythagoras for that wee triangle in there, r squared cos squared plus r squared sin squared equals 1. You can factorise out your r squared. Okay? Sorry, it doesn't equal 1. R squared plus cos squared equals your r squared. So that is a 1. So you see where you sort of go round in circles there. So that's how you find the length. Use Pythagoras theorem. Right, what on earth does all of this mean? Whenever it's given as tan theta, that's your angle. The length is 10 and the angle is 70. To get your x, remember, so there's your 10 and there's your 70. You're closing the angle down to get the x. So you just go r cos theta, 10 cos 70. And then to get your y, it's r sine. So that's your x and your y. Now, you can write it this here way. xi, remember I is what you go across. So I will go across 3.42i plus your y, 9.4j. Or you can write it as a column vector. The top number tells you what you move across, and the bottom number tells you what you move up and down. It's very strange seeing it for the first time, but you do get used to it. On this here wee vector, r theta. Now you can even think about this. I do it out here. There's 90 degrees. There's 180 degrees. 230 is going to be down here somewhere. So we want 230. So that's going to be 50 degrees because 230 minus your 180. So there's my line. Okay, so that wee angle in there is 50. And the length of this is 5. You want your x. So you're going to close the angle again. So it's 5 cos 230. And then for your y, r sine 230. And you'll get your negative values, what you'd expect. You're out your negative x-axis and you're down the negative y-axis. And the way you write that, xi minus your yj, or you can write it as the column. When you write it as a column, you don't have to write i's and j's anywhere near it. Okay, so that's going from vectors, or giving you r thetas into your x, y's, basically what we were doing there. This one here, we're giving it in x and y terms. So that means I'm going 5 across and 3 up. So how do I get my r? You see your right angle triangle there? So r squared equals 3 squared plus 5 squared. So my r is the square root of 34. To get your angle, if you remember trig, this is your hypotenuse, your opposite, and your adjacent. So it's tan 3 over 5 and gets you your angle. So you can write it as r theta. There's your r and there's your theta. Second one we're going to look at here. Right, so I'm starting here. I'm going -2 out and -4 down. So to get my r, I always draw out wee pictures of these. Pythagoras theorem for r. To get my angle, it's going to be inverse tan 4 over 2. Use your opposite over your adjacent. Okay, it's just me working it through there, just the normal way. That gives me the angle to be 63, but you start at the beginning. 180 plus 63 gives you your full angle. Then write it in r theta. Okay, so that's the basic form. I'll just recap that. So r theta, r theta. That can be split up into, maybe this is your I and this is your j. So along this one, your x equals r cos theta. Up here, y equals r sine theta. That can be written as your x and your y, just like a wee column vector like that, or your xi plus your yj. And remember what x is? It's r cos. Remember what your y is? It's r sine. So that's what we were looking at in the first page. Part B, multiplying by a scalar. Multiply each element is each bit. Okay, so you know your x bit and your y bit by the scalar. Remember, a underline denotes a vector, and a in its own, or the underlined a with straight lines denotes a scalar. Okay, so, and this is also the magnitude. Magnitude and scalar is the same thing. Remember, magnitude is a distance and scalar is just one dimension. Okay, this is much simpler than what I'm making it sound. If you've got this vector, now do you picture what's going on there? You're going out 2 and you're going down 3. So that is what your vector looks like. Okay? You want 4 times it, so you just times it all by 4. Simple as that. You can write it in a column if you want. Now, when you see it written like this, it's looking for the magnitude, the length of it. So it's using your Pythagoras theorem. 2 squared add 3 squared square root it. And it is looking for the length of 4a. So 8 squared add 12 squared square root it. And if you notice, that's root 13 and this one's 4 root 13. Another wee important example. If you want to minus the whole thing, just make sure you minus everything. Okay. C. Adding and subtracting your vectors. You add, subtract the corresponding elements. Okay. And the resultant is just the total. This nose to tail thing, don't worry too much about that at the minute. So if I have these 2 vectors, just add them. Add the i's, add the j's. So it gives you 2i minus 5j. Okay, so don't worry too much about that nose to tail stuff. Don't worry about that wee picture there at the bottom. And this one here, subtract them, subtract them. Okay, very important here. Position vector always starts at the origin. So you want to really make sure you understand that position vector starts at the origin. Okay, so now I'm going to have a look at example 6. When you're copying it out, if you colour code it the same as mine, A, B, C, D. Okay, D to A, the direction is so important. It's A, do it in a different green as I did mine in. D to C is C and A to B is C. I'm sorry, that's A as well. Now, I want to go C, oh sorry, that's all just written down there, A to E. Okay. A to E is B, so E to C is also B. A to B is C, we've talked about that one. I want to go C to B. so it's A. I then want to go B to C. I'm going backwards, so it's minus A. I then want to start at B and go to D. You can go backwards A, backwards C, or backwards C, backwards A. So just minusing. Doesn't matter which way you go. Part B. A to C is 2 B's. Or backwards A, forward C. So forward C, backwards A. As long as you have got the signs right, it doesn't matter what order you put them in. Okay, example 7. I just want to get it up here in this other screen. So example 7. A is the point 2, 4. So A is 2, 4. So that means its position vector, I'm going across 2 and up 4, starting at the origin. B is the point 5 minus 1. So its position vector, starting from the origin, is across 5 and down 1. So you use your I's and J's to denote your direction there, or you could write them as columns. Okay, flat is coordinates, columns is vectors. Now I want to go A to B. So I go backwards, forwards. So A to O, I'm going backwards. So it's minus 2, minus 4, because look, O to A is 2, 4. So if I'm going A to O, it's minus 2, minus 4. O to B, you have up here, you've all set out, just add them. Part 3, I'm going O to M. Now M is the midpoint of AB. So you have AB worked up out there, so find half of it. Okay. Now, to go from O to M, I'm going to go O to A, and then A to M. So O to A, you know, it's 2, 4. A to B, oh sorry, A to M, that should read. A to M. Yeah, there's a mistake there. A to M should be 1.5 minus 2.5. So that gives me 3.5 and 1.5. Okay. And E, the unit vector. A unit vector is underlined with a wee hat on it, and it's the vector divided by its length. So if you've got a vector, remember that's a vector. If they were written side by side, it'd be coordinates, so that's a vector. To find the unit vector, I have to divide it by its length. So you remember how to find the length or the magnitude? So it's 2 squared plus minus 3 squared, square root it. So your unit vector is your vector divided by 1 over 13. You can, if you want, write it like this. Or you can do what I did, factor out the 1 over 13. And then, or you can separate it out. So it's your x bit in front of your I minus your y bit in front of your j.